Hey everyone, good morning. Cheers. Oh, Matt, you're on time. What happened? Coffee on a cold morning. I got something funny to start with. I got to tell you all. Anyway, the microphone.
Fartman says Fartsian and chat.
Hello, Christian. So I did a bit of recording during the week and last week. Obviously, I had to record my announcement video for my Series D. Very quiet. Really? Anyone else with quiet audio? It's right up to almost into the red bars. No? Sure it's not your volume, Steve? Nothing's changed. Audio's fine? Okay. Anyway, let me know if there's a problem. Anyone else? Quieter than usual, but only by a bit. TDS was low because I've got my volume turned down, but Brennan's deaf, but he can still hear. A tad quieter than usual pre this microphone. I can do it, put it up a little bit. Just got to be careful. I don't want to keep hitting the red. Anyway, so I had to record my announcement video, and there's another video I'm working on. I know, shock horror, working on 2 different videos. Who is this person? Anyway, and twice last week I went home with my microphone left on here. I just forget it's there. You know, I stopped recording, so whatever, but then I'm just walking around the factory doing stuff and went to the post office and I'm, you know, whatever, and then, you know, no one said anything, and then went home and whatever, and then went to take my jacket off, my top off, and hit myself in the eye with the microphone and went, what? So, yeah, it's, I don't know. I'm not sure I'm liking the whole microphone thing and not having the brain capacity to remember to take it off when I'm done. But anyway, that's my funny story. It's working out of my daughter's well done badge on. Really? That's okay. A badge is okay, you know. And did you do a good job of going to the trade counter? But I mean, thankfully it's not recording anymore. That's okay. It was still on. It was communicating with the receiver, but I wasn't recording anything. But it's still just yeah. My old one I wouldn't have forgotten that it was on because it was big and chunky and like used to flap around on me. So coffee. It might be my second coffee this morning, but my first one was only a half a cup. Just saying. How's everyone doing? Been a rough couple of months. Just to let everyone know, we're a sick house again. Lynn got the flu, type B, brought it home, and so Yuz is also sick, and we're just waiting for me to get sick. Ollie, my daughter, won't get sick because she just lives in her room, doesn't let anyone around. Don't cough down the mic. The mics. Oh, you probably. I don't know if you were here. I don't know. So I didn't stream last week. I don't think. No, I didn't. The week before I did, when I was still sick and I was coughing a lot. The mic didn't pick it up, which is good. But yeah, I don't want to transmit through the thing. So I don't think I've got it. But Flynn's been pretty sick. We had to take him to the hospital the other night. Had to get blood tests and stuff. He had abdominal pains. So it's just crazy what's going around. Yeah. So I've dodged this one, I hope, I think. Okay, let's start with saying hi to folks in the chat, and then let's get into it. All the things. So Steve, SDG Electronics, Moo. You all know Steve's YouTube channel, right? Like, I don't have to, I mean, I'm happy to, but right, for those that just aren't aware, which there's got to be no one by now, it's Steve's channel, SDG Electronics. He does great reviews on soldering equipment and solder and irons, and does cool projects. Dishipu, oink, hello. Sean, good morning. Beata, hello. Brennan, hello. Why is your alias here not the same as your YouTube channel? I don't think it is. No, it's not. You should go to your. You should do your other one. This one. Okay, this is Brennan's Old Man Maker. I'm not gonna do this for everyone. Okay, this is just gonna take forever. Johnny, Moo, AJ, hello, Quack, Matt, good morning. Christian, hello. Bob, Burton, hello all. Hello back. Scrolling. Dutch Taurus, hello. David Essa, hi. Put a sign checklist on things to do on the back of the exit door. Take off micro. No, the first thing on the list would be read the list. And I'd have to do another list to remind me to read that list. I don't do lists. For some reason, I just can't remember to look at the lists ever. Bruce, hello. Christian Horteland, hello. I can always get that name wrong when I try to pronounce it. Oh yeah, I forgot I could just abbreviate the SDG electric. Sorry, I just did the link from your. If I click on the little dots next to your name, it says go to channel, and it does the other version of the channel. Okay, I think that's everyone who's chatted. There's more people than I've called out, but they haven't gone ping inside the window, so I haven't. Yeah, it's annoying. Although those names came very late, though. Like, if you recall, there was a feature that that came years after I joined up on YouTube, started a channel. I don't know why it doesn't just use the easy one. So for those that missed it, shame on you. But for those that missed it, I launched my Series D boards. Oh, they're available now. As of last night, they are now on my store, and they are on my Electrons store. So for those of you that are in the EU, or that, that want to have all the VAT and stuff taken care of for you, so you don't get those nasty, terrible fees for collecting VAT and stuff, they're available on my Electron store as well. And they're available on my main website. And boy, oh boy, this was a challenge for a lot of reasons, which I'm happy to talk about. but releasing these boards was a major channel. Sounds giving everyone the D. Turns out that, you know, if you do a Google search, and now Doom, what's Doom? What? Who? What? What about Series Doom? So it turns out if you Google Series D, then what you get is lots of information about Series A, B, C, and D funding, right? You get nothing about my boards. Oh, maybe one link buried somewhere. That's okay. It's new. I was tempted with the high wattage Gaboom or whatever it is. High wattage Gaboom. Right. Futurama. Never watched a lot of Futurama. I'll have to go back and watch it. Anyway, so, excuse me. And apparently Series D is the worst of the rounds, where you get the least amount of money for very little gain, apparently. That's the last money collecting opportunity in venture capital. So maybe Series D was a bad omen for my boards. I don't know. But it obviously stands for the D for dual antenna. But yeah, for those that aren't aware, oh, look at that. I can't even center my boards. Whatever. Oh, and we're upside down. Are we upside? We're upside down. Now we're not, except now I've got the little chat thing on the bottom. My Series D boards, I zoom in. Is it going to stay in focus? Maybe a little bit. See if we can focus. My Series D boards have both antennas on them. They've got onboard and UFL. And there's a little tiny, like less, it's tiny, it's 0.8 by 0.6 millimeter RF switch just in there. So designing these was a bit of a challenge. Here's some sunlight. My hands are purple. It's just, yeah, it's my camera. There's a setting on my camera that's just doing something weird with the color, and I don't know what it is, and I can't. It keeps going. Just heard about someone networking startup got a Series G funding. Really? I didn't even know that. Okay. Okay, I didn't realize there were that many. But I mean, everyone knows about Series A and B, like in terms of, well, not everyone, but you know what I mean. Like you hear about that a lot. But anyway, I'm glad I didn't call it Series F. Funny, I don't think I ever used Wi-Fi in any of my. Really? Yeah, but you don't. Okay, you do projects that don't need Wi-Fi. You use Bluetooth though, right? Sure, you've used Bluetooth. Anyway, quite a challenge to do this and to fit it all on to my existing boards. I attempted this several times over the last couple of years, and I couldn't solve it without making the boards much bigger. So I did have to make the Tiny S3 a little bit longer. It's 1.3 millimeters longer, and the Pro S3 is 2 millimeters longer. The Feather S3D is not, because it's got to be the Feather format. But I tried this many times and I couldn't crack it because the board had to become way too big. And then I found a solution. I'm not going to go through the whole story. I'm not. But I found this. Why is my logo over? Okay, see now I got distracted. 1 second. Because I don't use this view normally, but my camera is not normally on this, the way it's mounted right now. So I need to fix my logo because that is frustrating. And this is also not showing everything. Okay. There we go. So it's not so tiny S3 now. Oh, very funny. It is a bit bigger. It is. There's my tiny Pico. So as you can see, it is a little bit longer. It's not the end of the world, really. But anyway, so I thought I'd originally solved it. I found a special connector, a UFL connector, that had an insertion switch. So when you connected the antenna to the UFL connector, it would enable it. And when you enable that path, so you made your RF go through that connector, and then when you disconnected it, it disconnected the onboard, and when you pulled it out, it reconnected the onboard. And I had it all. I redesigned all my boards. I bought a stack of these connectors. I was ready to go, and the people who make the connector wouldn't sell the opposite side for that goes on the end of the antenna. It was a disaster. They wouldn't even sell them to OEMs to make antennas, and it was like I wasted so much time and money on it. And then I finally found a different RF switch that I could use, an external switch that was small enough that allowed me to squeeze everything on, but it needed 7 external components. Because it needed a whole bunch of DC blocking caps and stuff. And it was just, but I did it. I relayed out all my boards. I managed to squeeze it all in, and it was pretty ugly. And I got to the point of being able to test it, and I had prototypes here, and I was testing them, and they were okay. I needed to retune all of my RF stuff. Not the UFL side, but the onboard antenna. So I thought, okay, fine, I can retune all of that. It didn't perform terribly, but there were 7 unique components, and the only way I could fit them on the board was to make them 0201 components. So that was 7 unique 0201 components that I had to put on my line and add to my production, and then have to retune all my boards. And I was going to do it. Because I really wanted to have this as a solution. And at the last second, after I got my prototypes and I'd already panelized my boards, and I was about to send them off, the guy called Jeff from RF Components here in Melbourne, who's the Johansson distributor, amongst other things, or whatever else, pinged me and pointed me to a different RF switch that needed no DC bias, DC blocking components. It only needed 2 components. Well, actually, it only needed 1 component, just a cap on the power. And it also, the other component that I was using needed 2 I/O to switch. You had to turn one on and one off. You couldn't just use one. And I couldn't fit no, I did. I found, oh my God, this is all coming back to me really badly. So my first design had 2 I/Os, but I didn't have 2 I/O free on the Pro S3. And so I found a little NOT gate that was 0.6 by 0.6 millimeters in size. And my plan was to feed the I/O into one side of the RF switch, and then through this little tiny NOT gate into the other side. So when it went high, it was high, and the other one would be low, and vice versa. And I had no idea if it was how that was going to work in terms of latency and stuff. But I actually got prototypes made and got them delivered, and I was about to assemble them. And on that day, he pointed me to this other switch that only needed 1 I/O and only needed 1 cap. And I had to add a second component, just a bias resistor, to ensure that the onboard antenna was always selected by default. And so again, I scrapped all my designs and redesigned with this thing. So I went through about 6. I went through, I think, 7 prototypes for my tiny S3, and then in total 6 prototypes for all my boards before I even got to the Edge S3D. A lot of you might remember this was already done. Do I have it here? Where'd I put it? So I built one of these on stream, but it didn't have the dual antenna. Do any of you remember? Hey, Miss England. So it was a bit shorter and it had just the single antenna. And I thought to myself, what's the point of releasing a new board? What's the point of releasing this at the same time as my dual antenna stuff and not make a dual antenna? So I then redesigned this and made this dual antenna. It's been about, the first time I tried doing this was a year and a half, almost 2 years ago. And then this whole process now has been about 9 months to get it to this. What are we talking about? We're talking about the weather. Okay. I don't even know if anyone's interested in this story. Whatever. It's fine. The point is, I did it. It's done. They're out. And the cool thing for me on this is I only have to make half as many boards now. Half as many boards, because I used to have to stock onboard and UFL versions of every one of my boards, or every one of these anyway. I still have to with some other ones. We'll get to those. And so I would always be out of stock of one or the other. I would always be short in quantity. I'd always, if I was making a batch of boards, I didn't want to just, because I used to sell a lot less external antenna ones than I did onboard, probably 3 to 1. But I was always running out whenever I needed them. Someone would order some and I wouldn't have enough, right? Or a reseller would order and I wouldn't have enough. And it was always the issue of, where do I put my components? Where do I put my components? Like, I'm chewing up components, making boards that could just be sitting there for months and months while I've run out of components to make other boards. So now I only have to make one of each. And it means my resellers only have to stock one instead of 2 of each of these boards, which has been a problem. I'll happy to talk about that. Deshipu asks, did you have to retune all the RC circuits, the RF circuits? So no, interestingly, I didn't. In fact, so what I did instead was I didn't have to make the boards bigger, but by making them bigger, I was able to keep my tuning the same. If I would have not made them bigger, or if I would have done something stupider with this battery and left it on the back, pointing back or whatever, then I would have had to retune all of my boards. But it turns out that these perform better. Not that my other boards were bad. My other boards were great, right? But these actually perform the same or better in both modes than what my previous boards did. And that was just because I took a lot of care. It's really hard to see in the picture, but I took a lot of care. Maybe I can point to it. If you look at the area around the antenna, you can see there's some missing copper there, right? They're all the same. They've all got the same area around them, and they've all got, it's all been, anyway, I spent a lot of time on the design to avoid having to sit and tune, because I wanted all of the boards to use the same components. If you consider that I've got there's 5 tuning components, RF tuning components per board. And if I have to make any of them unique, that's really, I go from 5 to possibly 7 or 9 components that I'm taking up space on the machine. They're not cheap components, right? We're not talking about, 1 cent or 2 cent caps or inductors of whatever. These are RF components, high Q values, whatever else. One of the capacitors on these boards are like 7.5 cents each, which big deal, 7.5 cents US. That's, you work it out, a reel of 10,000 of them, 7.5 cents each, is a very expensive reel of components. So, anyway, I didn't have to retune them. This one I had to play with. I had to actually play with quite a bit to get the tuning okay. So this is good. This works just as well as the other boards. But again, the issue with this is, well, we'll get to it. Oh, I can show you now. The point where I hold the board down is fairly close to the antenna, right? So if I use a metal screw here, it detunes the antenna a little bit, depending on where the cable is sitting. Okay. So if the cable's sitting like this, then a metal screw here detunes a little bit. If it's sitting like this, it doesn't. But if I use a nylon screw here, it doesn't. I mean, I can even have it sitting over like that, and it doesn't detune the antenna. And when I say detune it, we're talking about a little bit. We're talking it shifts everything down to the lower end a little bit. So it's, you know, by far not terrible in any way. Like, it's as good as any board I've ever done or had. But you can definitely see the difference. The problem is getting nylon M.2, that's an M.2 screw. Getting a nylon M.2 screw is, I'm sure you can get plenty of them from China, but getting one locally or getting them when you need them is quite difficult. What's the range difference between the two? Let's see it on the VNA. No, let's not. Let's not. Not today, anyway. Excuse me. Maybe I'll look at doing it. I can do a video of that. So that was a challenge, working out how I'm going to hold the board. I couldn't stick anything in the middle like a normal M.2 would be. It had to be off to the side, and it couldn't be near the onboard antenna. It had to be near the external. So what was it? There was a question. What's the range difference? So it's hard to like. I can't tell you what the a range difference is, but like if I, excuse me, when I run my test. Okay, let's just do this. Hang on. I don't know. Let's go this. If I do it, I'm just gonna. Actually, I don't know what code's on here. I'll have to flash some different code. Okay, I can put some code on to see if, or maybe, wow. Close that, close that, close that. Wow, what just happened here? Okay, let me see if I can. Okay, from a USB connector. Change this to feather. Feather S3. Okay, I'm just compiling some code. So this is just what I was originally using to test the RF switch. So this will, it just does like a Wi-Fi scan, right? Oh, hang on, I need to turn my hotspots on. Hang on. Oh, oh, oh. My testing point. Oh, they're on. Whoops, must have left them on. Okay. So this is going, what this does is cycles between, here we go. Oh, I need it. Sorry, it's stuck under my thing. Oh, can't really see it on this. Can we see it on this? No, we can't. So what it's doing, it's cycling between the different, I don't know where I grabbed this board from. I just need to untangle my USB connector, my cable. Somehow I've wrapped this around my test jig. Whoops. Okay. Wow. There we go. Well, maybe I'm just going to hang it. Let's hang it. So this is so you see here it cycles through the different antennas, right? It's gonna keep going. It's annoying. So it's seeing 17 networks of the onboard and 18 with the UFL, and so you can see here that my network is getting minus 42 on channel 9, right? And you can see the different ARM networks here, all my different testing points downstairs. And so the same network is getting 44.
Chat has disconnected.
Oh, come back. Okay. Which cables are supposed to be shielded? The ones on the antenna. Yeah, but they're so small and so thin, they're still susceptible. So you can see here, right? You know, it's on the Feather S3, it's fairly close because the tuning is really good. Right, so I'm getting, 17 on one, 18 on the other. Sometimes I'm getting a lower reading, sometimes I'm getting a higher reading. But doing a Wi-Fi scan isn't it's not testing range because it's not using transmission, it's just using receiving. So, people who do a Wi-Fi scan to test how good their antenna layout is, it's the wrong way to do it, right? You need to actually connect. So when on my test jigs, and this has been a real part of this interesting story of, I didn't realize there are a lot of things I hadn't considered when I said I'm going to make these Series D boards and release them. And one of them is on the test jigs, testing them, which I'll get to in a moment. But the way my testing process works is it actually connects to my test APs. I've got a whole bunch of test APs downstairs. So it doesn't just, it scans for them, builds a collection of them, and then it connects to each one and tests its time to connect. And it has to be under a certain threshold or it fails it. And so that's testing transmission, not, it's testing TX, not R, or it's testing both, but you need the TX component. Hello, Blam. What are we talking about? Some of the boards use rubber locking pins, nipples to lock. Oh, no, it's not a problem. It's the screw and the detuning is not a problem. Like anyone that's going to be placing one of these on a board, if they do, for them to find a solution to keep it in place isn't an issue, right? It was just an observation. I have actually I don't have any M.2 nylon screws here, but yeah. Anyway, what was I getting at? The point is, anyway, so that just gives you an example, right? Picking up 16 to 18 networks here is pretty good. Here, this scanner did 20. It found 20 networks, right? Now it's getting as low as negative 40. Wi-Fi is a really interesting thing, right? Wi-Fi, a lot of people, like I'll get, people ask support questions. I'll say, I'm having trouble with my Reflow Master Pro or something connecting to it, or one of my boards connecting to it. I know it's not my Wi-Fi because it's sitting right next to my router. I'm only a meter away from my router, so that's not the problem. And I go, actually, that is the problem. That's part of the problem. That's not how Wi-Fi works. Wi-Fi doesn't go from your board to your router like this, right? Now, with high frequencies, line of sight, people talk about line of sight. You need line of sight. Like, for 5G works better. Sorry, 5 gigahertz works better. Line of sight, 6 gigahertz, But then what they're not talking about line of sight specifically. What they're talking about, I'm just going to go back to here. What they're talking about is nothing in the way that will not reflect the signal. Reflecting the signal is fine. It's not reflecting the signal is a problem. The way Wi-Fi works is the signal is bouncing everywhere, off every surface all the time. And that's how it gets from point A to B, by bouncing, not by direct. There's no wire that goes between the two, right? It's a fallacy. And the closer you are makes no difference, right? If you got one here and one here, and nothing around to bounce the signal, that is bad. That's going to give you worse results than if you took one of your things, and went near a wall and allowed it to bounce. That will give you a better result, right? Nothing in the way will not reflect. Nothing in the way that will not reflect the non-existent signal. Or if there's no signal, that's a different story. We're not talking about no signal. We're talking about, anyway, I can't even remember why were we talking about. Why was I talking about bouncing? I can't remember. Anyway, use the seeing machine to map the Wi-Fi signal in the room in through. Oh, really? Do you know where that? Do you have that link? How long ago was that? So the problem with the higher the frequency, the harder it is for the signal to bounce off certain types of materials. So that's the issue. Like concrete, thick concrete walls. The higher the frequency, the less things bounce off it, or the less spread you get off it. Which, so when people talk about line of sight, what they're really talking about is no obstruction, no big obstruction that's going to prevent the bouncing. Okay, no worries, Johnny. Okay, I'm I'm going to stop talking about bouncing things. So we'll get to the oops thing. The oops thing was pretty funny. Actually, I'll show you this oops thing first. I was hoping to have my so I've designed a carrier board. This is the carrier board, and it's already on GitHub. Not this version, the fixed version. It's already on GitHub. I need a screwdriver, and I need to move this the other way. Okay. So I was hoping to have them ready to launch at the same time, but the PCBs are on the way now. The panels are on the way, because I made a bit of a whoops. It was an exciting thing I did, and then I made a bit of a whoopsie. This is not the oopsie on my thumbnail. This is a different oopsie. This was Sion was rushing and was very careless. So on the carrier board design, if you look at that was the original one. That was the original one when I didn't have the dual antenna and the mounting point was on the other side. But originally I just had a hole, and I was going to assume people would stick a screw in there and put a nut on the bottom or whatever. They'd work out their own solution for how they were going to hold the thing. Is that not in focus? It doesn't look in focus. Right. So did I hit that? Sorry about the moving camera. I'm trying to focus it. So at the last minute, the very last minute, I found the exact height and size SMD nut, or patch nut they're called. So this sits, do I have a board, an empty board? Not nearby, I don't. I might have chucked them because they're no good. So this gets soldered onto the board. And in this particular case, I couldn't find one that was only 1 millimeter in length. This is 1.5. So my PCBs I've got coming are 1.6 millimeter thick. Thanks, Johnny. I'll have a look at that after the stream. Thank you. So this one sticks out a little bit through the bottom, but the point is that gets soldered on, and that gives you your screw point to hold this in. Now, the M.2 connectors I'm using, these connectors, the Amphenol ones, they're not one of those ones where you go in on an angle and then you push it down for friction. They're an insert friction. So as they're pushed in and they're held in place, that's how the contact's made, right? It's not a rotating thing. There's different types of connectors. So I got really excited. I found them. I ordered a whole bunch of them, and I quickly changed the design and sent it off to get fabbed. And when they came back, I noticed that, whoops, I forgot to move this track. This track is going right through that, and oh, here's two more I forgot to move. So I killed the board, as in I can't use those I/O. They're all shorted. So, I mean, the rest of it I could use and test, but I shorted all the I/O through here, adding this on stupidly because I rushed it because the board was already at JLC PCB, and I had to quickly reject it because it was about to go into production, quickly reject it so I could upload these new ones, and I didn't check it properly. Silly me. Anyway, my new Can everyone hear that? Wow. My new version that's coming is all fixed, and their boards are black, and they're on their way, and then I'll have these in my store. Yeah, I skipped the DRC check because I thought, not a big deal. I just, what did I do? I just added this footprint. I was more focused on the paste than I was on making sure that it didn't fail DRC. Silly. Anyway, so my plan, I'll have these in the store, the new ones, the fixed ones, black ones. I'll have them in store, available for people to buy if they want something to go along with their Edge 3D boards to test, whatever. But the reference design is already on GitHub for those that want to make their own or use it to whatever. So that was my first foobar. I did that a little while ago. Silly. But this is the one. This isn't a foobar, but it had an unexpected issue that I hadn't considered. But before we do that one, electronics, are you against MIMO and spatial streams? What? Hello, Cypher. Against MIMO, argue multipath creates more issues than it solves. MIMO actually does create a lot of issues, interesting issues. I've found, especially with the Unify products. In my case, it wasn't the one side of the board thing, Dishipu. It was just I didn't even think. I was just in a rush. I was in such a rush to get it in. I didn't, because once they put the board in production, they won't cancel it. Right? And they'd already all been approved. So they were about to go in production. So I had to quickly cancel it. And then I was just a rush to get it back. Anyway, whatever. Stupid. Learned my lesson. I mean, it was a $2 board. It wasn't the cost of the board. It was just the delay. Yeah, okay. Maybe it's a ubiquity issue. I don't know. Hello, Volt the robot. But I found a lot of weirdness with my Unify network at home. Whenever I set up the multipath stuff and whatever, is I have devices becoming parents that shouldn't be parents. And I've had it set up a loop where they'd parent themselves in a loop and nothing would go back to my UDR at home. Anyway, the router, just weird things. So, and it also, you get a lot more spamming of data. It's anyway, maybe it would work under a much wider distance, but using something like that in a home environment where individually the APs are overlapping anyway, I don't know. I've seen worse. I've seen degraded performance, and it might just be ubiquity thing. I don't know. I don't have anything to compare it to. I've got Unify here. I've got Unify at home. Yeah, I don't know. Now we'll talk about this one. So I normally, when I build a test jig, this is my test jig adapter, right? It goes into, here's a test jig. Zoom out. Wobble. Sorry. Here's the test jig. Does that fit? Almost fits. Okay. So goes in here. Obviously this is not connected right now and not powered. That goes in there. And then when I'm testing the boards, right? Each board gets inserted into here, right? So it goes like this, it sees it, and I hit the test button. Yep, no problem. Testing was going great. Testing lots and lots and lots of boards. And then all of a sudden I started getting some fails. I started getting fails on I/O when it checks the number of I/O and make sure they're okay. But what? You're going to do logo, then rainbow. Cypher, the question is, why would you be learning how MIMO sounding works at that level? Was that just for fun? Was that something you do for a living? So I started getting some fails where it would not find USB, or would not, when it checking all I/O, it would say I was missing 1 or 2 I/O. That was a loud snapping sound. Did that clip? It went bang. Anyway, and so it turns out something that I hadn't considered, which I should have, but it's never really been a problem before, is these connectors aren't designed to have 100 boards inserted and removed, inserted, removed, inserted. What is going on? Now my desk is moving. It's falling apart. But constantly inserted and removed, right? They've got a, I don't even know what the contact count is on these, but M.2 is not really designed, like, you're not supposed to be inserting and removing your SSD 100 times a day. And so the longer I was testing for, the more often fails would happen. And it was getting to the point where I had to push harder and harder on the board to get it to pass the tests. So initially, on a brand new one, like here's a new one that doesn't have headers on it yet, right? When I put the board in here, it's a really tight, that's a tight fit. It's satisfying. It doesn't click, but it goes in really well, right? Look at the difference. You might, I don't know if you'll be able to see how, can I get that closer? In focus. Will that be obvious? Right. Look at how less this board is stuck in than this one. Can you see that? The amount of exposed ENIC? So these connectors degrade over time, and the more I'm inserting and testing, the worse they get. So I was going from a really, perfect pass rate, and I knew the boards were fine because I inspected them. There's no problems with the boards, to lots of fails, and it was because I couldn't hold the board in because the contacts were getting loose and just the connector was degrading. And so all in the past, everything I was testing was either with pogos like this from my RMG, okay, so they don't really wear, or they were pogos like, like this, right? And this is the first time I've had something where I'm inserting and removing again and again and again, and so it's degrading, and it still works. So if I put a board in and I put pressure on it like this, it passed the test. But I can't do that with my finger because it fails the antenna test, right? I'm kind of blocking the antenna. So I need to come up with a solution that has, I'm going to do a 3D, because I normally make like 3D things that go on the board to hold or whatever. I need to design a thing that sits at the end here that is spring loaded, even just with elastic band, that grabs the board here and pushes it against the connector. Because if I push it against the connector, it passes. And if I don't, it won't pass. Or 50-50. Never considered, sure, I could just make 50 of these, 50 adapters, and, use one, like every 50 times I test a board, I then chuck out the adapter and get a new one. I can't hot air them off once I've got the headers on. It just gets destroyed. and I can't get it on a hot plate once the headers are soldered on because it won't fit. So what did I miss? I'm working on implementing sub 1 gigahertz Wi-Fi FPGA block, which supports because of the. Okay, you lost me at no. Okay, very cool. Is that just a fun project, or is this a work project? Yeah, 200 to 300 megabits over 1 kilometer range would be awesome. Very cool. So, yeah, again, it's just something I just didn't consider. And so it got to the point where I was testing these boards where I was getting so many fails. Like I've got a pile of boards now that I know are good, but they fail a lot of the time on this jig. And I need to come up with a solution that holds the board in place better, at least for now. And I'm not expecting to make thousands of these boards. Like I don't think it's going to be, a board that I sell thousands of, just because of the nature of what it is. So it's not like I need to, solve this at scale, but I need to solve it to the point where I can't have it. Like every time I do a test, let's say it's a 60-second, right? That's the other problem. It's a 60-second test cycle. So my Tiny Pico is a 20-second test cycle. My non-D series boards were a 40-second test cycle. And now my Series D boards are a 60-second test cycle, which I know, big deal, an extra 20 seconds. But it adds up. When you're sitting here with 3 test jigs in front of you and you're testing boards and they're taking over a minute each, like that's and you've got 1,000 plus boards to test in a session. That's a lot of extra time. I mean, it's a lot of extra YouTube I get to watch, sure, but yeah. So I need to solve the not having to test it twice to bypass the first fail. Does that make sense? Like it didn't even occur to me this was going to be a problem. And I can claim ignorance because I've never done one with an insertion connector before. But the fact I should have thought about this, because all the connectors I buy, I look at the how many times that you can insert on them, because they've got different ratings, and often I'll look for components that have a higher rating for better longevity. But this is not designed to be switched over so many times. Right, I'm babbling a bit now. So the other challenge was testing the Wi-Fi and testing the radios on my test jigs. So I originally had 3 APs set up downstairs, one on channel 1, one on channel 6, and one on channel 10. Was away, now back. What's the issue? Insertion number? Oh, Bruce. Well, yeah, the degrading of the connector after, putting in a board, testing it, pulling it out, putting a board, testing, pulling it out. Eventually, I started getting false negatives because of the degrading of the connector. It was getting loose, wouldn't grip the edge as well, couldn't push it in as far. Anyway, yeah, the solution is multiple adapters, and I need to build a mechanic, which I'll get to. I'm going to try to do it on stream, although we're already almost an hour in. Sorry. Something to hold it in place, other than my finger, or trying to jam one of these things onto it to kind of get it in. which I was doing for a little while. But my test jigs, so I've got 3 AP set up downstairs, and on every jig, when it's testing a board, it would connect to all 3. Hey, Alan. So connect to the station 1 version, check the time, 6 and 10. And if any of them was over 4 seconds, it would fail, and or it would retry. But if it couldn't get it the second time, it would fail it. And there's legitimate reasons why sometimes it won't get it the first time, and that has a lot to do with how congested so they're just running Tiny Picos with MicroPython in AP mode, right? So that allowed me I could write my own firmware for that side, which can register the connection. I was logging them at one point, but there's no point logging them. There's so many boards. Like, it's pointless what I'm going to do with all the data. But it allowed me to connect to it, set my own security stuff, and not have to worry about other people in the area seeing it and connecting to it, stuff like that, right? But there, if I've got one test jig going and it's testing one channel at a time, no problem. But then I add 2 test jigs, and I've got boards who sometimes one will be doing the radio test while one will be doing it, flashing it. But eventually there'll be a time where suddenly it's trying to test 2 boards connecting to one micro at the same time, right? And, eventually it just gets a bit choked up and might fail a connection. And then when I add a 3rd test jig, it just gets worse. And then when I add the dual antenna, where I have to test all 3 channels on the onboard antenna, and then all 3 channels on the UFL connector, right, adding an antenna to it, I've doubled the amount of noise and comms and bandwidth and whatever on those jigs. And it was becoming a real problem. I was getting a lot of false negatives. So what I did was I added an extra 3 APs. So there's 6 there now. And so 3 get used for the onboard and 3 get used for the UFL one. So when it does a scan, it finds them all, puts them into 2 different lists, and it tests them. All the UFLs get tested on one set and all the onboard on another set. They're all sitting next to each other. They're all around the same area. So it's the same test, but I had to double the number of APs to reduce the number of false negatives because of congestion. Running an ESP32 MicroPython on a Tiny Pico with an external antenna is not the same as going out and buying a proper Wi-Fi AP for connections, right? They're not designed to have so many simultaneous connections, and they're nowhere near as fast and nowhere near as reliable, whatever. They're good enough for my testing, but I was getting all these, I was testing boards, and then all of a sudden I'd be getting all these fails on Wi-Fi, and I'd be looking at the boards going, there's nothing wrong with this board. And then I'd try it again and it would work. And then I'd try it again and it would fail. And I couldn't work out what was going on. And it was the congestion. But doing the 2 lots of tests adds 20 seconds to the testing run. So there's, as I said, there's been a lot of, and then I had to obviously change all my testing processes to be able to deal with the whole dual antenna thing and testing from the right place and whatever. It was quite a fun challenge to get to the point of being able to test all my boards reliably. Got to remember, I've been using these test jigs with the same firmware on them, testing the same boards the same way since 2021. And to have to go back and reinvent it all for the dual antenna was a fun challenge. Anyway, I don't think anyone's listening to what I'm talking about. Everyone's talking about what Cypher's doing, I think. I'm just reading back through the chat. That's fine. Sorry, that was a joke. Sorry, bad joke. Okay, so By the way, all this is solved now, except for the holding the board in place. And I've already tested 250 Edge S3s. Like, you know, I have plenty of stock of Edge S3s now that are tested and passed, and I don't have to solve this thing instantly, but I still need to solve it. So close that and go to here. So this is like the example of what I've got for my OMG S3, right? This is how I kind of build these things. So I need to do the same thing. I need to come up with a 3D print thing that uses the same 3 peg legs. That's all I've got to work with, although I probably only need 2. And need to come up with a system that will allow me to clamp it in place. Yeah, I'd have to still not. Yeah, there is no fancy AP. That's the problem. So finding an. So here's the thing. I need to be able to test different channels, and my experience with only. No, that's not true. With a Ubiquity AP that I tried, and with I'm trying to remember the brand of the AP I tried. Can't remember what model it was. That allowed for multiple Wi-Fi on multiple channels. I had a lot of issues with them. I couldn't get, once I went beyond 2 channels, 2 Wi-Fi networks, right, unique networks with different channels, I was getting just lots of issues. I couldn't do it, right? And I needed minimum of 3 channels. And they're also really expensive. And if I needed to change one or fix something on it, I had to reboot the whole AP, which then I lost all my channels while I was testing or whatever. At the time, it didn't even occur to me that I could be using a MicroPython board. I can't remember what the router was. I ended up returning the router. I can't remember what it was. I got it from Officeworks. Probably not the smartest place to buy it from, but it was like $600 or something. And I got it specifically because it could do multi-channel Wi-Fi. But it was just terrible. It was really, really bad. And even at home, I've tried setting up multi-channel Wi-Fi, and it doesn't work great. And I've tried it here as well. My problem here is I've only got one AP. But at home, I tried it where each AP was connected to a different Wi-Fi on a different channel, and it was just terrible, like really, really bad. So MicroPython all the way. And MicroPython's not the bottleneck; it's more the ESP32 that's the bottleneck. And it's just, you know, still buggy, always been buggy. Okay, so I've got the Edge S3 adapter here. I just need to put it into this project. Oh, I like how it all the way over there. Why is it all the way? Did I just find another bug in KiCad? Might have just found another bug, or did I not have I just moved to KiCad 903, and that is not correct. Adapters, Edge S3. Ah, where's my? It's lost my. Interesting. Oh, this is annoying. Won't be a moment. Okay. I really hate the snapping now in KiCad 9. Really don't like it. Why? dead at 0. Export. Step. I do like that they've got the GLTF export now, and they've got things like filling vias. But I had drill place set for the origin, but there was no drill place, but there should have been. I'm not sure where it went. Okay, let's try this again. Upload. No, I don't want to upload. We want to import new version. Yeah, I want to upload. There's that bug where the trace ends up going backwards when you try to pull a label. Yeah, it's still got quite a few bugs. Hey, Mad Techie, it is better. They fixed some of my griping issues in 9 so far, but not all of them. So problem is once you go to 9, you can't go back to 8. So I'm stuck in 9 now. Oh, come on, Autodesk. Look how slow this is. You think the other residents will be mad if you run out naked in the rain? Yeah, probably. Excuse me. Okay. Here, I need to say get latest version. Please put it in the right spot. It might not. It might. Oh, no, it did. Good. Okay, that's better. So you can see I've got it here. Model. So they're the 2 posts I've got. That's where the USB connector is. Where's all the rest of the... Where's the USB connector? What is... I mean, it doesn't matter, but where are all the components? So there's a bug when you import stuff from 8 to 9. The last time these projects would have been opened, like when I designed this board, that was in 9, but I would have loaded an original layout from KiCad 7, maybe. Go 3D viewer. Oh, see that? It's dropped all my models. So it's kept the resistors and the caps. And I've lost all my other models. So they got lost when I imported from 7 to 9. Oh, that's annoying. Okay, whatever. I'm not going to fix it now. So many things. So what I'm thinking is, I'm going to duplicate this, and I'm going to call it S3 clamp. And it's not even in the right spot. Excellent. Let's move it to the right spot. Where are my little handles gone? What's going on? Look right. Good enough, I think. Cool. Okay. So I'm going to start with just need to chop some of this off to begin with. And this is just the quickest way I can think of doing it. I'm sure there's a better way. Extrude 2 sides. I said 2 sides. No, symmetric. Right. Bye. Oh, did I not go far enough? Whatever. Bye. Wait, I want to delete that. Oh. Try it again. Extrude. Symmetric. Bye. Okay. Ugly, I know. So what I'm thinking of doing is, I wish I could sketch in here, as in with a pen on the screen. I want to have I don't mind destroying this just for now. So the idea is that I had something like this. And I need this, how big is that? This needs to be 1 millimeter. Okay, so if I had something like this, right, the actual board sits 1 millimeter off. When it's inside the connector, there's a 1 millimeter gap, which is why I needed that patch nut to be exactly 1 millimeter high. I don't want to have this all the way underneath, right? I just probably want a little section here that sits under because I don't want it to interfere with the radio transmission when it's testing. But
Alan Madsen says OHHES. Congratulations on the new Series D.
Thanks, Alan. It is both exciting and I'm tired. It was a lot of work. So what I want to do is have a trying to think the easiest way to do. Maybe I'll just design it and show you. Create a sketch. Okay. So if I have something here, obviously there's pins in the way there, but that's well, I'll work it out. Doesn't matter how big that is, and it has a
Alan Madsen says yes, I can imagine, but well done and at extremely reasonable prices.
Thank you. Someone said to me today I should up my prices, and I said to them, I've not upped my prices ever. I did for a very short period of time when all that craziness happened around COVID and the shipping prices went up and whatever, but then I dropped them back down again a couple of months later without even saying anything to anyone. People didn't even realize. And yeah, and I've never dropped my price. I've never lifted my prices, and I should. I should. But I'm not gonna. So this is very badly designed, but that's okay. Because I just want to show you what I'm thinking. Very badly.
Alan Madsen says never say never, because never is a long time.
It is a long time, but It is. It is a long time. That probably won't have enough leverage, or maybe it will. Okay. So I know this looks crazy, but here's what I'm thinking. Oops. And don't worry about how hot, how thick it is or whatever. I'm trying to come up with something that's really easy for me to do right now. Extrude that, whatever, 2 millimeters, just for the moment. So if I had this, and so that could swivel on there, and I had an elastic band that was between here and here, that would be my spring. Then what I could do is, if I use my thumb, I could push that, which will pull this away, right? It would, what's going on here? Why is it, why can't I set the pivot? Why is it? Okay. So it would allow me to rotate that like this, right? Which will have spring, like it's pulling the elastic band.
Alan Madsen says make a small notch in it for the elastic to fit into.
Yes, I know. I'm just showing, I'm showing what the idea is, right? And so that would give me my stretch, although I need to get a better angle. And then when I let go, it'll push the board and hold it into the socket. Does that make sense? So I don't know if it's going to be easy to get the board in and out. Like, opening this up like this with one hand, like it needs to be done with one hand, so I can use the other hand to get the board in. But this might be enough. That's not rotating the right spot, but this might be enough to have it hold it in place and get rid of all of those, get rid of a lot of the issues. And it's a fairly easy thing for me to print and try, right? But of course, that's not going to work because there's a USB connector there. So that's going to go right through the connector. Hey, Dave. Oh, quiz night at the pub. Everyone is good. I think everyone is good. How are you? So I need something that's got a bit more lip. I think that's not going to have enough on it, enough spring to hold it. And I need something that can sit in and yeah. If you shape it the right way, you could get away without any rubber bands or springs, a bit like those wood vise things. No, I want to use the rubber bands. I want to be able to tension it. I don't know. I've got to be careful how hard I push the board. And also, like this contact surface here is way too wide because that's going to interfere with the radiation of the antenna.
Greetings, mortals.
Hey, Quixotic Geek. Greetings. So, like, there's a lot. Like, yeah, there's So this should really be more like in terms of a shape.
Geek says, what are jaw making?
Hang on one second. So it needs to be more, something more like this because it can't interfere with the ant. Shit, wrong one. I'm just roughing out an idea for a clamp to, you know what, this, yeah, so that's going to be in the way of the USB. It needs to be more something like that. So 1 second, I can't talk and think at the same time, obviously. Interesting. Oh, that's made a mess, hasn't it? Okay. Let's try that again. Something like that, right? Anyway, an eccentric. I know what you're talking about. Right, it's like an eccentric nut. But again, I can't tension it. The only way I can tension it or adjust it is to reprint. Right? I need something. I want something that I can add a rubber band or remove a rubber band or remove a twist from a rubber band. Yeah, I don't know if I would be able to do it with one hand. So, okay, so here's the thing. Quixotic Geek and Dave, who's come in late, he's probably going to fall asleep at the computer screen. So this is my test jig for my Edge S3D, and I need to design a 3D printed clamp that attaches to these points here, because they're the only attach points I've got, that clears the USB connector, that is springy, as in it's got tension that can hold the board in place like this when testing, keeping in mind that there is an external antenna connected and the onboard antenna, and I can't use my finger because that interferes with everything, and whatever the thing is can't interfere with the antenna, so it's got to be a very small contact point just about here that puts pressure on the board and holds it inserted so it's not loose. See that? So how easy? And this is all because it didn't occur to me when I designed all this that, see, this one doesn't do that. This one is locked in solid. This is a new one. But I've run over 150 boards through this one, and every time I insert it, remove it, it's loosening and damaging the connector. And so I start getting false negatives, false failures, because it's not making contact properly, because the board won't sit in properly. So where before I could just plug it in like this and it would work every time, the more I remove it, like there's got a lot of tension. There's a lot of pressure to get this in. It holds it really well. But this one here now doesn't. It's really loose because of how many times I've inserted and removed it. So I'm trying to design a clamp that'll hold it in place and see if that will give me more longevity out of this. Otherwise, what I'm going to have to do is completely change this design and use maybe a vertical insert one. So one that inserts this way. Sorry, my hand is in the way. One inserts this way. And then I can use a clamp vertically on it or something. I don't know. Or maybe gravity will help. But these connectors are not designed to have something inserted and removed hundreds of times. You have to plug the external antenna manually too, right? Yeah, that gets plugged on before. That gets added to the board before, like this, and then the board gets inserted like that. All right, and then the clamp. So the idea is if I could use my thumb, I don't know which way, like whether I go like this with my hand and use my thumb to do it, or whether I hold it like this. Obviously, my hand's in the way of the camera, but for me, that's not too bad to go like this and then let go, and that puts pressure on the board. And it should be an easy thing for me to try. It might not work, right? It might only give me an extra 10% longevity. I could usually have a spring type deal. Hey, Quindor, how you doing? Right, I mentioned this before. So there are lots of different types of M.2 connectors. This is a horizontal insert. So this one here is not one where you put it on an angle. My hand's in the way. How do I do this?
Alan Madsen says, aren't they enough if it's just kept down?
No, as I'm saying, different types. This one here that I'm using is not one where you go like this, yeah, and then as you push it down, it makes contact. This is a horizontal insert. This one is designed to go, there is no angle. It inserts like that and stays like that, and the screw here holds it in place, but it doesn't need the screw. I did this on purpose. The ones where you need to put it in on an angle and then hold it down, that's great, except I can't just do this with it and test it and try it. I always have to screw it in place every time to hold it into place. Now, sure, I could try to find a different connector and do something like that, but then my option is I need to put this on, and this has to hold it down in place instead of screwing it, right? So I don't want to be, to test every board, I don't want to be having to screw it in to every board. As it is, it's 1 minute to test this board. If I have to screw it in and then unscrew it and put another one in, screw it and unscrew it, we're talking about 2-3 minutes per board that I'm testing, which is just, I can't do that. Like it's yeah, not only is it taking too long to test these boards, but while I'm doing all those things, I've got other test jigs sitting here idle because I don't have time to change them because I'm too busy fiddling with this, right? It's got to be a much quicker process. And the horizontal works great. Like it really does. Like it's actually like these are not cheap connectors. I found some Asian brand ones that were much cheaper, like less than a quarter of the price. But I needed something that was reliable. But I didn't consider what M.2 connector is designed to have things inserted and removed 100 times or more. Like, who would do that on an M.2 connector on a motherboard? No one, right? So that was the bit I hadn't considered. Some type of plastic wedge that sits between the USB socket and this. Right, but how do I get the wedge in and out to have it push enough? So I was doing that already. I was using this bit of rubber underneath the board with the clamp, and the clamp was, I loosened the clamp so it wobbled, yeah? So when I pushed the clamp down, I pushed it on an angle so it had horizontal pressure on the rubber pushing the board in. And that got me past the 100 board mark. It did. But it's really like it was fiddly to get on and fiddly to get tight, and I was still getting some false negatives, and all it was doing was actually damaging the connector more because it was putting so much pressure on the connector that it was just getting looser and looser and looser quicker. And a loosey-goosey connector is not what we want. So it's designed to have pressure horizontally, but I'm going to be very careful with just horizontal. If I'm putting pressure down and horizontally, all I'm doing is I'm putting too much flex inside and I'm loosening the connector. Yeah, it's not designed to be a test jig. These connectors aren't designed to be a test jig. Put an idea in the live stream chat. Who was that? What? The vertical insert. Yeah, I looked. That's what I'm saying. I could go to a vertical. The problem with a vertical is I don't have a lot of clearance. Like I have to rearrange a few things on the test jig to be able to do that. I definitely can't use a clamp to hold it, and eventually I'll still get the same problem. But when they say 1,000 inserts, they're not. It's not 1,000 inserts because it's 1,000 inserts where you perfectly get the board in straight, perfectly straight vertically, and then perfectly out and have no flex, right? And it's like these pins on this connector, they come out of the socket really easily. like if I get my tweezers and run it along the thing, the pins fall out. Like it's really, they're not too optimal. What no. Is that what it says? 1,000 inserts or optimal inserts? No, I don't need a robot arm. I just need something to hold it in place, or I need, yeah, it's, anyway. So people don't think this is a good idea. Oops, no. So I don't think people are liking this idea. I don't know. I don't necessarily have a problem with it. As long as I can clear, I don't know if that'll clear the USB connector. I'm sure I can design this so it'll clear the USB connector. Treasure them as mating cycles. No, yeah, it's a mating cycle. Sorry, yeah. How many cycles you can do?
Alan Madsen says yes. That's a good idea and quick to use.
For the angled insert connectors, there are latches that aren't screwed. Snap. Yeah, but I don't have a place to connect them. Those latches won't work on my board. They'll latch onto a component, knock a component, be on a component. Yeah. I just told it to open. Oh, why did that not open? Sorry, I'm checking out Bruce's link. Oh, those things. Yeah, no, I can't use those. So Bruce was referring to something like this. Right, but that still needs me to have something mounted there to connect into. Possibly. M.2, where's the, it doesn't have any size, design stuff. That's just a slide. Okay, that's not what I was thinking. I was thinking of the other sockets that have the little the thing on the side that's part of it. I wasn't thinking of this. 3D printing a latch. Well, I don't know how I'd 3D print something like this that can latch like that. Yeah. So your one, that won't work because it's not an angle insert. It's not. It doesn't need to hold it down. It needs to put pressure horizontally across. It's a horizontal, not a down. Does that make sense? So this isn't going to work. I need, the board gets inserted horizontally. This will be in the way. This will be in the way. The board has to be put, okay, unless I change connector, the insertion of this has to be horizontal. It's already flat and in. There's no angle. I can't do it this way. I can't see what I'm doing. Right? It's insert like that. It's not angle and down. Wrong connector. I'd have to change connector, change footprint, redesign my board, redesign my carrier board, and I've got hundreds of these connectors. So, yeah. And this is just for my test jig. The carrier board's fine. The carrier board has the patch nut, and people screw it in. Right? It's designed to be you screw it in and it stays there, and it stays there till you want to remove it. Right? It's not an in out, in out, in out, in out. So, but for the test jig, it's an in out. Like every minute, I'm pulling a board out and putting another board in. But I don't know how I'm going to do this, and I'm going to have to, I need the USB connector on there at least. Yeah, it's lost all the files. KiCad. Models. So many. What? Where's my USB connector? That's not my USB connector. That's just funny. Oh, that one. Okay. So if I re-export that, I'm just curious. Uh, 0.8 millimeters. The board, Quindo. Dave's going to sleep. Catch you later. See you, Dave. Whoops. Oh, I need that screen there. Okay, close. Import new version. Come on. Hey, Peter. How you doing? Missed the start. Yeah, by a lot. I'm playing with a pair of caliper. Feel like you could use some stiff to adjust ones. How would I use calipers to clamp? Where the caliper's going to sit? You're all avoiding the issue of it's. I'm completely constrained around that space. This has to fit on an existing boards I have right here, right now, adapter boards. I can't redesign the adapter board to fit something else because then it won't fit in the test jig. So I have to redesign the test jig. So where and calipers aren't. I need something springy. Like I want it to use the same amount of force all the time. I want the force to be from the spring, not from me over tightening, under tightening, etc., right? It needs to be right. So see, there's a USB connector. So I need something that's going to oops. That when it opens, might just have to read it. This sketch is a mess now. What's it? So I've got that there. I'm constrained by header pins by the USB connector, right? So that can't rotate in. So God, I don't know this mess here. That's what happens when you just do quick sketches in Fusion. You end up with an absolute mess of stuff. So like this would have to be able to come around. It doesn't need a lot of room. But it needs to be able to get out of the way. get out of the way enough that, and it doesn't need a huge amount of strength. Under the pump, Peter. Not good. Like, I reckon that needs to be out there. The further away, the more leverage. Oops. All that. Oh, fusion. You're so funny. Actually, probably don't want that there. Probably want it more there. Just to hold the elastic band. Yeah, it's too big, this circle. Oh, look what happened here. That didn't work. Didn't work at all. I'm not constraining anything, right? So when I change something, move something, it does not like it at all. I don't know if that's going to work like that. Oh, why is that on there? Did that again. Okay, anyway, I still have to work out how. Why does the pivot point have to be on the board? It doesn't. My plan was to have it higher, but having it higher is going to make it really hard to print. So like as it is, it needs to attach to these things. So pins going down and up, whatever, and then like, yeah, I need to. Well, it needs to be. So if you think about it, if I'm pivoting up here, but the thing that's touching it is 10 millimeters lower, 8 millimeters lower, and it's really tiny to push the board, it's going to have lots of flex on it. Like doing it like this, if I can get this working, means that I don't have to worry about flex. Okay, that's really annoying. I really need to clean this up. You know what I need to do? I need to do this. Should have done this at the start. Okay. So it can be like this. It can go No, it's still going to be the same issue. So I need something to support the board, which is what this bit is here, although that's, I don't want it so wide. So I need to change that. Or I could have this. Also go under and support it, but either way, this stupid way of doing it. Far out. Just for the moment. Yeah, okay. Like I think this, yeah, the elastic band is going to be in front of the USB. Like if I do a multi-height, could work. Anyway, I don't know how I'm going to get the board in and out doing this. That is not a lot of give. If I go to here, I go. This is like, that's not a lot of room to get the board in and out. Yeah. But it's got to be better than what I had. So the easier thing, you know what? Through all of this, so I don't know who it was that said it. Someone, could have been Matt or someone else. No, not Matt. Said something about putting something that squeezes between the USB and the board. Who was that? I don't know who that was. Maybe this whole lever thing is overcomplicating it, and maybe I make something that uses a spring from a pen, right, or something that I can put the board in and then insert it. You said a wedge, but I'm not talking about a wedge. I'm talking about something that still has spring. Something I could insert here and then remove. I've got to be careful wedging. Yeah, I don't know. I want something that's got some flex to it. Like I don't want something that's solid that I'm putting that much hard pressure on, because I also don't want to damage the board. Like I can't see something like this lasting very long. Yeah, I don't want to 3D print a spring. Not really. Because again, I don't want to have to reprint something to retension it. I should really disconnect that. Yeah, I don't want to have to reprint to retention, especially if it wears out.
Alan Madsen says print at block between the USB and the PCB and TPU.
Right, but again, I'd have to reprint to tension to reprint to tension to reprint to tension. But trying to think what else I've got. It's a shame of the horizontal insert that how much clearance I need to get the board in. Man. How much length do I need? Eight 8.25 millimeters. Ah. You got to remember, I'm visualizing in my head me sitting here trying to insert, wedge, test. Is it a fail? Is it not a fail? Do I have to jiggle the wedge? Do I have to jiggle? You know what I mean? Pull the wedge out, pull the board out, put another board in, get the wedge, get it the right orientation, put it back in. You know, how am I getting it in to give it enough pressure to push, but not too much pressure to push? You know what I mean? I'm trying to imagine myself sitting here with 200 boards in front of me that I have to test, and trying to picture how frustrating it's going to be doing it, right? So where you're all looking at how to solve the wedging something or the springy something, right? I'm playing out I remember what I went through getting these ones done, right? And you know, I've only got about 11 boards that I know are good, but for whatever reason don't test well in the test jig. Like that out of I think 180 boards I did, whatever, that's not too bad. But I had to retest at least 30 boards, at least 2 times, if not some of them 3 times. And you know, that's like at least an hour of my life that I lost doing that. So I'm trying to work out in my head what's going to be more pain than not. Does that make sense? And then always in the back of my mind, although this is kind of silly now, I guess, because it's never happened and I can't see it ever happening. But in the back of my mind, I'm always thinking about how would someone, if I got someone else in to test the boards, how would they do it? How would, like, if it relies on me to wedge something in there and to work out the kind of exact tension and make sure it's blah, 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 how's someone else going to reproduce that? Like with a lever, with a latch, that's really easy. You pull it and you let go. But wedging something in and out, can anything attach from the other end that sits over the board? No. Nah. Firstly, because if it's sitting over the board, I can't get something in and out. And there's only one little corner for it to attach to, and I need access to the buttons that are on there. And yeah, so the answer on that is no. I thought about that. How do I pull something around it to pull it? You know, elastic band, whatever. That's not really an option either. So again, I have to solve this on the constraints of my test jig adapter, because any change to the adapter means a change to the test jig, and that's just lever that locks the board via the mounting screw hole. Now I thought of that, but it's doing it at the wrong point. So I tried that when I was testing, and just by putting, so when it was loose, I lost it. Where is it? Oh my god, it's on the test jig. I'm an idiot. So just by putting pressure there didn't work on that corner, because it was giving me pressure on the corner, it wasn't working up there. I'd get IO failing here, right? It needs to be in the center and pushing evenly because they wear out differently. So this one, I'm not sure if you can see, it goes in more on this corner here than on that corner there, just because of the nature of how I've been holding it and how I've been wedging it in. Not only does it get loose, but it's not even. And so the more I put pressure on one corner, and so the other problem is that there's header pins in the way, and the board's only a millimeter off the thing, and it can't be higher or lower because it doesn't make good contact. And so that gives me no place to stick something in here that can hold it and rotate. And it's going to also clamp it where the antenna is. So yeah, that mounting point here doesn't help me. It needs to be, and even doing it here is problematic for the RF, but at least that central point there is better because it's before the tuning of the antenna and it's hopefully far enough away from the UFL connector. But it really needs to be there, and the board has to be perfectly flat, and it's got to be held in place and not be metal. Ah. I don't know what a leaf spring is, but either way, like again, I don't know. Like it can be mounted on here. It can be something that mounts there. Like it doesn't have to be like a wedge that is something that I have to take out, put the board in, and put in. But it also can't, if it sits there all the time, it can't get in the way of me inserting the board. And you got to remember, I got to insert the board. Like it starts like I've got there's an antenna. So there's a board I've got in my hand, right? I need to hold the jig while I do it, and then I need to get the board in, get my fingers as low as possible because I don't want to put it too much of an angle because it's not designed to be on an angle. It's just going to, by starting on a high angle, I'm putting too much pressure on those pins. I'm bending them out of shape. It's got to be a horizontal insert. And if I'm starting from here, I don't have a lot of clearance here. Like whatever's going to sit here that as a spring, I don't have the fidelity with my fingers to push the spring back to get this flat to then have it push in place. I've got header pins in the way. Like I'm scraping my fingers on the header pins to try to do it. Again, I'm totally constrained by this design. If you see here, I have no space. I can't make this wider, the header pins, right? And I can't use surface mount ones that don't go through the board because I need like the board's PCB's got to be much wider. So I can't get rid of these. I can't move this. The button's in the way. Like, you know what I mean? Like I'm really constrained here through my own fault, but I've got too many jigs that use this process. Use a top insert, put 4 on the board just for where the mount. Yeah, well, I thought of that. Putting 4 on the board is a problem. I can't have them all wired up at the same time. I'd have to have some way of switching the signals, and there are too many signals. So, yeah, so it'd have to be a single. I can't do multiple. But I thought about doing a top-down one. But top-down, it doesn't help me other than gravity holding in place. It doesn't help. I still have to eventually, in and out, they're going to wear, and I'm going to have to put pressure on the top. So whether I'm putting pressure from the side or the top, it's the same problem. Pressure on the top is in some ways easier because it's not blocked by all this here, and it's easy to get the board in and out, but it's also hard because I've got nowhere I can attach something to push the board down. Now the antenna cable shouldn't be an issue if it was top down. It's not, doesn't really put that much weight, but it will fall down like this, right? It'll, it'll go like that. And I don't want the antenna sitting on the test jig. Like I want the antenna clear. So yeah, I might have to hold the antenna out in space. there's so many different things. Again, none of this occurred to me because I've never had an insert remove. I actually thought this was going to be really cool. Well, it was for the first 75 boards, 80 boards, right? I thought to myself, this is going to be really cool because I won't need to put pogos and I won't need to build some 3D contraption. And I could just, I don't have to worry about clamping it. And I can just get the board, put it in, and test it. I was actually excited by not having to put a clamp down and not have to, do all these things. How fast is this going to be? Never occurred to me the wear and tear. Like I figured I'd get 1,000, 2,000 out of it. I didn't think they'd degrade this quickly. And they did. They degraded really. Like they degraded less than 100 inserts. It was the issue was becoming obvious. Probably about the 75 to 80 mark is when I started seeing a couple of little things, but I could easily fix it just by giving the board a bit of a nudge. But then once I got past 100, that nudge was a nudge and hold, and then it was becoming and you're right, 100's too low. Well, if I make stacks of them, the other problem is I'm now out of these EEPROMs, and I've ordered some new ones, like a third party, whatever. These are microchip EEPROMs that I use. They need to be a specific EEPROM, unfortunately, because I can't, like they all have to be detected the same way with the same code. I think I found a third, like an Asian brand one that datasheet looks close enough, maybe. I've got a whole bunch of other ones that are different package type that I can move to, but yeah. But I'm out of these, so they were my last two. So it's not like I can just make 20 of these boards, and that will solve the problem, right? How many boards do you need to test? I'd use the vertical insert connector. Excuse me. Use the vertical insert connector and make the jig to allow you to mount it sideways. Mount what sideways? A vertical. I can't redesign the jig. I don't know what you mean. How would I redesign the jig to allow me to put a vertical connector on its side? A vertical connector can't be on its side. What? I don't understand. We're talking about 67.5 millimeter pitch pins. How am I going to mount them sideways? A PCB that's on a PCB that's on a PCB? Like, yeah. Excuse me. Unless I'm missing something obvious, Matt, that I don't know. But yeah. The good news is I've tested all my boards and I've got this other one I just have to header pins on. So that will solve the 11 or 12 boards I need to do here. And that gives me enough for now. But I can't leave this for future Sion because what will happen is I'll get an order for them, like a reseller order, and I'll have to go and make more, and then I'll be down 2 test jigs and have no solution. So this is something that I do need to solve fairly quickly. Oh, maybe some thick foam. Maybe just some thick EVA foam I wedge in between. Might just be enough. I don't know. That would be easy for me to try, wouldn't it? Could I try that? Just I mean, that'd be hilarious if that was enough.
Madsen says, can you unsolder that connector and solder a new one on?
No, not once the header pins are on. I can't, unfortunately. You can't. If I hot air it, the only way to do that is with hot air because there's no room to put hot plate, and the connectors disintegrate. I mean, I could redo the adapters with a low temp paste. Maybe that will help a little bit. But yeah, the connectors are very temperamental. I actually destroyed a couple of connectors already. Stick it all in a centrifuge. Could steal the. Oh, I can get the EEPROMs off. If I'm going to destroy the board, I can. Just bear with me 1 second. I had an idea. This would be hilarious if it works, even if it's just temporary. How am I going to do this under there? I can't use that jig. Just bear with me a second. I'm going to. Do I have a cable that's long enough? I don't know if I do. Maybe. Okay. Let me log out. Oh no, that was stupid. I didn't want to log out. I wanted to sudo shut down because I need to move it. Get away. Okay, that's shutting down. I'm going to move that over to here under my camera. The connectors cannot handle multiple in-outs when you're unexpecting a high failure. Knowing that the connectors cannot handle multiple in-outs. No, they can absolutely handle multiple in-outs, but not hundreds. How many people inserts hundreds of M.2 drives into their computer? No, so it's not an issue. Firstly, in the field, that's not my issue. In the field, people are designing their own carrier boards, putting whatever M.2 connector they want on, right? But my test jig use case is totally unique, and totally unique to M.2. I would have thought, because again, this is people they when they test a motherboard, they don't test the motherboard by inserting something 100 times into the M.2 slot. They test the motherboard by putting something in M.2 slot, drive, booting it up. Does it work? Yes. Okay. It works, right? Okay, so let's try this. Okay, this is a different test jig because I've got other software on this one that I need. This is an older one, slightly bigger test jig. Okay, got that. I got that. I'm going to take a board that I know failed.
Amory Jacko says the M2 connector is good for 50 matings or something.
Hey, Emery, I don't know. I can't tell you how many it's good for. I can only tell you from my experience of how quickly it degraded here. I'm just going to wait. I'm going to letting it boot. That's okay. RJ, all good. So, like, I was inserting and removing 180 boards in a few hours, which destroyed the connector. Like that's not what M.2 is designed for. So this was purely a my use case test jig issue. It's not something that I'm worried about in the field, because people won't be doing that. Even if they insert it and remove it 10, 20 times, 30 times over the life of their project, that'll be fine. I wasn't seeing issues till between 70 and 80, and then the issues were rare, but also on a normal board, you'd be screwing it into place, and that holds the board there, and that gives it its tension. In my case, I've got nothing holding it there. There's no, because I don't want to screw the board in every single time. Okay, I'm going to, let's see if this, wait, make sure it picked up the, yeah, Edge S3D. Can everyone read that? Maybe is the light in the way? Hang on. Yeah, that might be a bit easier to see. Okay. See, already I can tell this is just not sitting in well. But anyway, let's see what happens. Should be able to see, hopefully, the writing. So flash the UF2 stuff. Now it's mounting it. Now it's copying circuit Python. So there's no RGB LED on this board to indicate what it's doing, but now it's remounting. So it's looking for the USB drive, not a serial port. Now it's doing a test where it's doing the antennas. It's doing the onboard antenna at the moment. Hello, Big Bad Joe. Because firstly, there's no place on the sides to guide it. I don't need guiding. The issue is not about guidance. The issue is about holding it in place. Okay, so that passed that time. This is a board that failed before, passed this time. And again, it could just be just the way I've got it inserted in the board. So that's great. Let's move that one out of the way. That goes in a good pile now. I don't know if this is a good one, existing good one or not, because it's already been marked with a dot on the back. But we'll find out. I just want to wait till I get one that fails. And as I said, not every board failed 100% of the time. So, I'd get a board and it would fail, and then I'd, jiggle a bit, test it again, and it worked. And it's purely to do with just the contact. Yeah, I'm testing each one of these one at a time. Hundreds of them in a batch, one at a time. Just going to grab a whole bunch of these boards. Okay. I should make it show on the board, on the screen, what it's doing, but I'm looking at the logs on the screen. I can see the logs go past, so I know where it's up to. But you can see how long this whole testing process, see, that worked this time. Well, that could have been a good board because it was all the ones that were failed were not marked at the back. Oops, have not been marked. The 2 meg thing, right? That could have just been one I pulled out of the bag that was good. Half no idea. Blue tack. Yeah. I don't think blue tack is it not. Oh, I'm not sure that's antennas even. Shit. Okay, that's not good. Did that fail to copy? No, it finished. That's good. That's how loose it is that I touched the antenna and the board started coming out. I'm just going to go get a bit of EVA foam. You'll still be able to hear me because I've got my microphone on. Yay! Okay, there is a scrap of foam on the floor down here from making Squixel cases. I think this would be perfect to cut a piece off. Another pass. These are all passing now. How frustrating. I mean, yay, they're passing, but I want one that fails. That fails in a way that I can fix it. Okay, so I've got this piece of EVA foam, just a bit that was cut out. So let's grab here some scissors. Need to measure it. Have you placed a small L-shaped wedge about one? Yeah, that won't work. AJ, sorry, you missed a lot of stuff. It needs space to horizontally insert. So, okay, so that doesn't like that board. Power dipped, make sure you're providing enough power. Right, so here's one that did not work. But I think this is actually not, I think this is a bad board. Yeah, okay, I know. This one, I picked this one up and I shouldn't have. This is on the wrong pile. So you might have seen that the battery LED wasn't flashing. I've got a short or something on that board. Only one board, I had one fail when I was testing before. I mean, had some that failed the false negative, but I only had one that actually had a an issue on the board. Oops. Yeah, the board, I need room to insert. It can't be something that's fixed and stuck there. I'm just eyeing the little wedgie thing. I just cut a little wedgie thing. We'll try that in a minute. But I need to find one that fails. And look, this is the whole thing's going to be prove me wrong now. I'm going to sit here and they're all going to pass. How frustrating. Or how good. It's a frustration, but it's also a good thing. So I can just then just put them in stock. Yep, that one passed. We're out. Oh my gosh. I want to see if I can wedge that in. But I don't need to yet. Oh, that failed. That's stuck. That actually crashed. That's a no good. Try it again. Okay, so that crashed on flashing before because of how loose it was. So it was obviously had an issue with the D plus D minus pins, but it got past at that time when I reinserted it. That's one that just did a false negative just then. But it's still going now. I want one that fails on the GPIO. That would be easier to see. Unfortunately, the GPIO test is last. I should put it before the Wi-Fi because then it can fail earlier. Well, actually, in this case, it won't because it won't fail till the end of all the tests. It doesn't exit early when it fails. Unless it's a Wi-Fi fail. No, see, it worked. Oh, boy. I do want to see if this thing, what happens if I wedge it, or if I can wedge it. I mean, look already how potentially tricky it's going to be to wedge this thing in. Like, this is too much work to wedge it, right? Yeah, no, it's not even holding the board down. No. If I have to fiddle that much to wedge it, it's defeated the purpose. No, an angle connector with a latchy thing is an option for my test jig because I can, that's fine. Holding it down, I can use this. Right? So it can be an insert. I mean, it might be a bit hard to get it in on an angle with this in the way, but you know what I mean? But if I had the 1mm support underneath, I could hold it down with this clamp. That would not be a problem. But I have to source them. Yeah, they're vertical ones, but it's the same issue of holding it in place. And over time having a problem with it. It'd be the same insert removal thing. Wow. I just need to find a B key that's an angle insert that isn't, or I guess on the test jig it doesn't matter, but that isn't $5 a connector. Oops. I've actually got some B key angled ones here. Oh, where are they now? I'll have to find them. I put them in a box somewhere. Some of the earlier connectors I got when I was trying out different connectors, actually it's not a B key, it's an M key. Back when I thought this was an M key, not a B key. Excuse me. Yeah, the angle one clamp them. That they put pressure vertically down, which puts, yeah, so they don't slide in. They're like this. Hang on, let me just. Just move this out the way. So this is the one. This is the connector that's on the SSD on my Pi. So unscrew that. So it's that type, right? This is obviously the wrong key, the wrong connector, but so they go in an angle like that, and that is what makes them connect. So I could have this that does that. I just have to find the right connector, get the connectors, remake my adapter board for that connector, and then yeah. So I don't need to screw it in place. Okay. And that's a much more common connector than these ones are. But I chose this connector because I thought it would be great for getting in and out easily and not having to screw it to hold it. Right? Both for me and for people prototyping. And as I said, a brand new connector, like this is a brand new one that's not been used on the jig. This is quite a tight fit. That clicks in place. That actually is quite nice, right? See, it's not pulling it out or do anything. That works really well. But this now, look, a little tiny tug, and the corners come out already, right? It's lost all of its grip, all of its tension. So I'm gonna find one with the same foot. No, they're not the same footprint. They're a totally different footprint. Unfortunately. Yeah, you can't get the angled insert with the same footprint, but it's fine. The footprint's not an issue. I just need to get. It'd be nice if it was the same footprint, but It's totally different. The pins on these ones go out that way, and the pins on the angled ones, they both go to the left, right? They don't spread out like an IC. They go like this. So yeah, they're not compatible. That's okay. The boards are cheap. Like these, whatever. It's just I have to find it, confirm that the footprint's correct, and then reorder boards. But no big deal. This is the last one, and so far they've all passed. So I've just made an absolute fool of myself because they all work now, and I didn't have to make a little springy clamp, and I obviously have no idea what I'm talking about, and that was all just a waste. Rip it off, rip it off. What am I ripping off? What? Oh, right. That I haven't removed. Yeah, no, I haven't removed the plastic on any of them. Oh, is that what you're saying rip it off on? No, they're all on. This is my, yeah, no. They've all got plastic on them still. Is it really triggering for you? Sorry.
Alan Madsen says you just need to do tests when streaming.
That's going to be boring for everyone. I spent 2.5 days testing my Series D boards. Well, that worked. Okay, well, that's all of them, except for that one that there's something funky going on this board. I wonder if we can work out what it is. I don't know if this is going to be in focus or not, folks. Probably not. I don't know if that's in focus for you or not. I just want to see if I can spot anything. Oh, there we go. We're missing a diode. Where's the diode gone? How did I miss that? There's no diode there. Can you see? There's no diode.
Alan Madsen says looks great.
Let's put a diode on it. Let's do that. Let's fix this one. Beep, beep. Okay, it won't look great now. I don't know if that's good enough. I can't see this. I'm looking over on an angle. Okay, maybe. How did I miss putting a diode on that?
Alan Madsen says it's fine.
Thank you. Okay, it's heading up. I'm not even turning on the, what do you call it? My fan. I'm not even going to turn on my Save My Life. I don't deserve to have my life saved. Missing a diode. That's not bad. One diode missing on the whole production run of 180. So anyway, yeah, I spent 2.5 days sitting here all day testing boards, Series D boards before launch. That was so much fun. I watched a lot of YouTube, bit of Netflix, bit of Apple TV. Yeah. What? Okay, just waiting for this. It's only at 167 degrees. So yeah, I had 3 test jigs going, 2.5 days, and then beeping, each one beeping every 40 seconds to minute. So it was not like I could stop and, watch something on YouTube for 3 or 4 minutes and then go back or whatever. Like I was, every time I did that, I was losing 3 or 4 minutes of testing time. So it was this, and like I'd be watching stuff that I was really interested in watching, but I kept having to rewind it and watch the same thing again and again and again because I kept getting interrupted because of test jigs. Oh, it was so not fun. But it took me back to the days of having to test thousands. So, yeah. Well, it was 900 boards I had to test. Okay, that is fixed. So letting it cool down. Well, I hope that was all.
Time to hire the kids to do that testing.
They're not interested. My kids are not interested. They're not interested in helping. They're not interested in what I do. They are not interested in in anything. So, yeah, no. And again, because there are the false negatives or whatever that happened with my testing, like, it's just easier for me to do it. Yay, now it's flashing. Excuse me. Oh, sorry. Coughing into the microphone. So this board will have to go in the ultrasonic cleaner. Because of the fluxy.
To make it worth their while, for every tested board you get 5 minutes of YouTube access.
No, my entitled children think they're already entitled to 100% of their life per second on YouTube. Like, no, it's yeah. Well, let's not go there. It's complicated. We won't go there. Let's just accept that my kids aren't going to help, and it's me. Going to be me. When you have kids on the spectrum, then there's this thing where if they do something and don't get told they can't, then that reinforces to them that they can. And then once they think they can, you can't take that away from them because they can, because they were never told they can't. Does that make sense? Okay, that board works now. So that's got to go into the cleaner. So in a really bad analogy, really bad, okay? I haven't thought this through. Think of it this way. Someone goes, robs a bank and doesn't get caught. Therefore, they're allowed to rob banks because they didn't get caught and no one told them they can't. And then when they rob a bank and get caught, they argue that, but I'm allowed to because I did it before and I wasn't told I couldn't. That's the reasoning that happens in my household. Right? That's the reasoning in my household, especially with Flynn. If Flynn is explicitly not told, so if Flynn goes to the cupboard and takes out 10 Kit Kats and eats 10 Kit Kats, and we see him go to the cupboard, but we didn't see how many Kit Kats he took. He didn't hide them. He just took them and ate them, but we didn't count them as he pulled them out. And then the next day he goes to get 10, and the same thing happens. On day 3, if he goes to get 10 and we catch him and say, you can't have 10, he goes, yes, I can. I had 10 yesterday and I had 10 the day before, and you knew I was taking them out and you couldn't, and you didn't stop me, and I had 10, and that means I can do it. And so you gave you that's you giving me permission. And then if we try to stop him, it's a shit fight. So yeah. So the whole, you get 5 minutes of YouTube time if you help me test the boards. No, they've already got unlimited YouTube time. And anytime we try to negotiate that,
going to raid Cian's pantry. Apparently it's chock-a-block full of Kit Kats.
well, it's not, because he eats. It was getting to the point where so many, like, he'd go through two bags of Kit Kats in a day, and then complain to Yuz, there's no Kit Kats. Why haven't you got Kit Kats? She goes, well, why didn't you tell me there aren't any left? He goes, well, I only just finished them. And she said, but I only bought them yesterday. And he goes, yeah, well, I finished them already. Why aren't there more? Like, oh. There's a reason I work so many hours. Oh my gosh. Conversations in my house are the weirdest thing. Like, if you wouldn't know why, your mind would be blown with the conversations that happen in my household. It's all, if vending machine won't help, someone's got to stock it. He won't. He won't tell you when he's pulled the last one. He'll leave the empty bag in the cupboard, or he'll take the empty bag out and leave it somewhere, assuming we'll just see it, find it, and automatically understand that means we have to replace it. Anyway, so I've solved the problem by not solving the problem. That is actually quite frustrating. That is quite frustrating. That was, yeah. If I would have tried showing the issue at the start and then all the boards worked, like this was a pile of boards that failed repeatedly. They wouldn't have been in this pile if they hadn't failed. But if I would have done it at the start, then the whole conversation and the fusion time would have been unnecessary. Oh, man. I'm sorry, everyone. I apologize. Yeah, I apologize. I need to test these boards and put them in stock as well. Okay, anyway. My desk is a mess. So, folks, I think that's all I've got for you.
Matt says no apology needed. We're here for the process, not the outcome.
I'm glad, because there's no outcome these days, is there? Next time Mad Tiki gets pulled over for speeding, he said, you let me speed last time. You didn't stop me, so therefore I'm allowed to speed. That's the law. Yeah. You can try. Good luck. I hope it works for you. I do.
Alan Madsen says you don't have to apologize. It's just great that they work.
It is great that they work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 boards going to be back in stock, except I'm going to clean one in the ultrasonic cleaner. Yeah. Okay, well, folks, I'm going to go, I'm going to end this. End it. It's like ending my life. I'm going to close this down the stream. I'm going to go get a coffee. I'm going to pack these. Do I have any bags here? I have to make some more bags. Oh, I got one. Ooh, I have one bag. One bag. So, yeah. Oh, I got this on the back of the card. I've got that on the back of the card. Can everyone read that? Not compatible with a computer motherboard. How many people are going to try it anyway? Hello, Michael. Just in time for the end of the stream.
Alan Madsen says, so the next one that order get 11 PCB. Please smiling face.
Yeah, I'm going to put 11 in one bag. Yeah, no, I've got more bags downstairs.
Matt says, but I plugged it into my PC and I released the magic smoke. How do I put it back in?
I'm waiting for people who are going to try it and see what and it's going to end badly. I don't even know if B key is common on a computer. I think it's usually M that I've seen. I don't know. Have you tried it to see what happens? No, because I don't have a PC here that's got an M.2 connector that I can plug it into, right? And it's the wrong connector on the Pi. so it won't plug into that. But still, I'm pretty positive that it won't go well. Go on, go on. I don't have. If someone wants to send me a motherboard that's got a B key connector on it, I'll blow up their motherboard, no problem. Excuse me. Yeah, I'll give it a go. I don't have one. I honestly don't have one. And again, I'm not like the reason I chose the B key is I'm pretty sure it's not very common on motherboards or anything.
Alan Madsen says the most common keys for SSDs are B key, M key, and B plus M key.
Oh, so it is B key for SSD? I've only seen M. I'm pretty sure the ones I've ever the SSDs I've ever bought for any of my things have only ever been M. I'm pretty sure. Okay. Well, if B key is common, maybe does someone want to send me a? We should get BitLooney to send me his little PC thing he uses to test his M.2 boards.
Alan Madsen says a Wi-Fi module is E key and a plus E key.
Okay. Well, there you go. Right, so AJ's only got M key. Hey, Jonathan in London. Right, so which is NVMe M key? That would be M key, right? Like, I'm pretty sure the Mac has M key in it. I don't know, maybe not. I don't know. Anyway, the point is, hopefully no one will plug it in, and definitely no warranty if they do. But yeah, one of these boards. No, I'll do it later. Okay. I don't know. I'm looking away, coughing because of the microphone, but it's not using that. It's using this one. My newer Intel Mobo also is only M key. We need to stop buying Intel Mobos and get a Mac. I know you got a Mac, an old Mac, but yeah. Is that too soon? Too soon, AJ? AJ has a hate-hate relationship with a Mac. Yeah, NVMe is M key. Yeah, I'm pretty sure all my Macs are M key. Not that I opened them up for anything, but in the past anyway. Okay, thank you all. Not a fan of those gilded cages. Oh, so not gilded cages. So no. Anyway. Bye everyone. Thanks for watching. I hope you all have a good week. And no. I got something. I got to cover the label. I got something in the mail yesterday. Not mail, courier yesterday. I'm not doing it today. Not happening. But maybe next week. We'll see if we get Atomic 14 on the stream. I wonder what it is.
Alan Madsen says, well, Adam and Eve ate an apple. And how did it go?
What? I don't know what that's about, Alan, but okay. AMD is MK only. Yeah. So, yeah. Okay. Bye, everyone. Catch you later.